Okay, next we have module 5. Module 5 we have algebra. Okay, so in algebra, first of all we have to find what is algebraic system. Okay, algebraic system means a set with some properties. Okay, a set with some structure, it is known as an algebraic system. So before that, algebraic system consists of a set with an operation on the set and the properties which are taken as the axioms of the system. And these properties are main bone of this algebraic system. Okay, so there is a set with some properties. Okay, before that we have binary operation. What is meant by binary operation? So binary operation on a non-empty set A is a function from A cross A to A. Okay, ordered pair A cross A to A. That is, if we have to assign a relation from the set A to itself, that is, we get the ordered pair AB, and that if AB goes to C, that C also belong to the same A. Okay, and if there are n array operation, that is, the function is from A cross etc., that is binary operation. That is A cross A2, that is a function from A cross A to A. Suppose in A there is ABC. Okay, so A cross A means we have to assign, we will get a ordered pair AB, so that is associated with the element C. Okay, so this A and B are related and it goes to C, and this C belong to the set A itself. So that is what is known as binary operation. For another example, if it is A is equal to 1, 2, 3, and we are defining A cross A by the sum. Okay, that is 1 plus 2. You take any two element from this set 1 and 2. What is 1 plus 2? The operation is plus. 1 plus 2 is 3. Is that 3 belong to the set A? Yes, 3 belong to A. So we can say that this plus is a binary operation. Okay, so here this is known as the binary operation. And if there is A cross etc. cross A, that is n tuples A1, A2 etc. An, that goes to an element in the same set A, we can say that it is a n array operation. Okay, so that is n array operation. Next one is algebraic structure. Algebraic structure, a system with a non-empty set A, and there are some operations in binary or some array operations are there, and it is known as algebraic structure. That is, there is a set A and some functions f1, f2 etc. f3 are there, fn are there, and relation r1, r2, r3. Okay, so algebraic structure is a set with a structure. These relations can be addition, subtraction, etc. Okay, then what are the properties of algebraic system? What are the properties of algebraic system? So properties of algebraic system. Properties of algebraic system. So let A be a non-empty set, and addition, multiplication are the two binary operations. So which are the two binary operations? A set A is there, two operations are there, addition and multiplication. And which are the properties? First, closure property. If the plus and dot are defined as binary operation, What is the meaning of binary operation? An ordered pair AB is associated to the same element in that set, that is, it is closed. That is, if A plus B is equal to C, C belong to that set itself, it is known as closure property. So from the word of binary operation, it is understood that closure property is there. So no need to writing the closure property as a first property. Okay. So anyway, what is closure property? Closure property means if A and B are two elements in the set, then A plus B. Here we have defined the operation as addition multiplication. So A plus B should belong to A itself, and if the operation is multiplication, A dot B should belong to A. So these are the properties of closure known as closed one. Okay, so closure property means if you define the operation and we get the result in the same set. Okay, take any two element from the set and apply the operation, we get the result in the same set. Okay, then only it is said to be closed. Second property is that associativity. Associative property. So in associative property, take three elements A, B, C in A, and A plus of B plus C is equal to A plus B plus C, and A dot of B dot C is equal to A dot B dot C. Okay, that is, we can add in any order and find the product also. That is known as associative property. Third one, distributive law. Distributive property. So according to distributive property, three elements are there in A, B, C. A plus of B dot C. What is A plus of B dot C? So in distributive property, there are two operations, addition, multiplication. Together we have to apply. So it is A plus B dot A plus C. Similarly, A dot of B plus C is A dot B plus A dot C. Okay, so they are known as distributive property. Next one is commutativity. Commutative property. So commutative property for addition is A plus B is equal to B plus A, and for multiplication is A dot B is equal to B dot A. Okay, so it is known as commutative property. So next one, identity. Existence of identity. So identity element denoted by small letter E. Okay, or identity ഉണ്ടെങ്കിൽ അതിനെ നമുക്ക് small letter E ആയിട്ട് denote ചെയ്യാം. And for addition, A plus E is equal to A. That is equal to E plus A. So this is the property of identity. So if you add an element to A, we get the same A itself. So what will be the identity? So this implies what is the value of E? We can understand that this is equal to 0. 0 is the identity. And for multiplication, A dot E is equal to A. That is equal to E dot A. So what is E? So it is understood that A is multiplied with an element to get the same A. So what is the E? It is 1. Okay. So 1 is the identity for multiplication and 0 is the identity for addition. Okay. So that is very important. Generally identity element is denoted by E, but for addition in identity element is 0 and for multiplication it is 1. Next one is inverse element. So these are the properties of algebraic system. Inverse of an element. Suppose the operation is addition. So inverse is such that A plus B we have to get E itself, that is equal to B plus A. So this B is known as inverse of A. B is the inverse of A. So what is the inverse if the operation is addition? If the operation is addition, E will be 0 and B will be minus A. Okay. And for multiplication, A dot B is equal to E. We have to get A dot B is equal to E. That is equal to B dot A. And we know that if operation is multiplication, E is 1. So what is B? B is 1 by A. Okay, B is 1 by A. So these are the inverse. Inverse and identity are very important property. Okay, so A plus B is equal to E. That is, B is known as the inverse of A. If A dot B is equal to E, B is known as the multiplicative inverse of A. Okay, so that those are inverse element. Next one is cancellation property or cancellation law. Cancellation law. That means if for multiplication, if A dot B is equal to A dot C, what this means? B is equal to C. Okay, that is left factor A can be cancelled. And if A plus B is equal to C plus B, in addition, also we can cancel this B to get A equal to C. Okay, so B is the right factor, here A is the left factor. It can be right factor for multiplication and the left factor for addition also. So these are known as cancellation law. Okay, so these are the properties of algebraic system. So if there is an algebraic system, it must satisfy some of these properties or properties. Okay, and we can name a set A with the operation, binary operation, such that satisfying some of the properties or all of the properties. Okay, then it is having a name also. Okay, so properties of algebraic system: closure property, associative property, commutative property, existence of inverse element, and cancellation law. And we can examples. Suppose Z. So which properties Z has? Z satisfy the Z means set of integers. Okay, so Z is satisfying the closure property, because if you add any two Z set of integers. Okay, we have to define the operation also under addition. So any two integers can be added, we get another integer. So closure property satisfied, associative property also satisfied. Then distributive law, because in the case of integers we can define these properties. Then integers, commutative property also satisfied. Commutative means if 1 plus 2 is equal to, what is 1 plus 2? It equal to 2 plus 1. Okay, so commutative property is there. Inverse is also there. Why it is inverse? Why there is inverse? If for to consider an integer minus 2, what is the inverse of minus 2? Plus 2. Okay, if you take 2, the inverse is minus 2. Minus 2 inverse is plus 2. So inverse is also belong to the Z. Then cancellation law holds. Okay, so Z is an example. Integers under addition. What about set of integer under subtraction? Under subtraction, suppose what about the closure?
We have to apply the operation that belong to Z. So closure property is satisfied. Is it associative? Associative means we have to consider 3 element minus 2. Suppose for example 1 minus 2 and 3. Then under this operation 1 minus of minus 2 minus 3 is equal to 1 minus minus 2 minus 3. Okay, so we have to apply subtraction between the numbers minus 2, 3. Okay, are they equal? No, they are not equal, because subtraction is there. Subtraction is not commutative. A minus 1 minus 2 is not equal to 2 minus 1. Okay,
So this also does not hold. Okay, so that under subtraction is not satisfying some of the properties of algebraic system. Okay, is it clear?